Dear friends, in this video we will be discussing about the projections of solids. Objectives of this video is to explain projections of solids clearly, demonstrating using a 3D AutoCAD models and guiding drawing projections in AutoCAD. The contents of these presentations are this: classification of solids and projections of solids. And the definition of solid. A solid is a 3D object having length, breadth and thickness. They are bounded by surfaces which may be either plane or curved or combination of these two. The division of engineering solids. Whatever we are seeing, everything is all solids, but engineering solids are different from what we are seeing. The engineering solids are having a particular the shape and size with the predefined dimensions, so that is why those are called as engineering solids. These engineering solids can be divided into two main categories. Those are polyhedra and solid of revolution. Again, polyhedra can be divided into two categories, then that is regular polyhedra and irregular polyhedra. The regular polyhedra are bounded by the planes which are equal and regular. Now for example, here whatever you are seeing, these are the regular polyhedra, and this is the tetrahedron which is bounded by three triangular equilateral triangles. This is the cube which is bounded by six squares, and octahedron and dodecahedron. So these are regular polyhedra, but we are not drawing the projections of this regular polyhedra, and we are actually concentrating on irregular polyhedra. Those are two different types, prisms and pyramids. So these are called as prisms. The prism consisting of two bases, one is bottom base, another one is top base, and this bottom base and top base are connected by vertical faces, and these vertical faces are bounded by vertical edges. And if the base is a triangle, equilateral triangle, that prism is called as the triangular prism. If the base is bounded by, it is appearing like a square, that is called as a square prism. If the base is a pentagon, so pentagonal prism, hexagonal prism, octagonal prism, etc. So the prisms consisting two bases, the bottom base and top base. The bottom base consisting the base edges, these are called as base edges. So triangular prism consisting total 6 base edges and 3 vertical faces. If it is a square prism, it will have total 8 base edges and 4 vertical face edges, 4 vertical faces and 2 base edges, top base and bottom base. Likewise, we need to imagine the solid such that we can able to remember the solids. Now next category of solids are the pyramids. So here are the three types of pyramids are given, and square triangular pyramid, square pyramid and pentagonal pyramid. If you observe the triangular pyramid consisting one base triangle, and this is connected with the one apex which is passing through the center of the with the axis of the prism, pyramid. So this is called as apex, a single point that is connected to the all base corners of this triangle. So this is called as a pyramid. The pyramid consisting of 3 base edges, and the slant edges, this is called as a slant edge. It consisting 3 slant edges, and this face is called as triangle, is called as a slant face and one apex. So the triangular pyramid consisting 3 slant faces, 3 slant edges, 3 base edges, 1 base, 1 apex. And the similarly square pyramid consisting of 4 base edges, 4 the slant faces, 4 slant edges and 1 apex and 1 base. Likewise, all the pyramids will be having apex. And you remember, whenever pyramids are said, it will have apex. Whenever prism is they given in the question, you need to remember that the prism consisting of vertical faces. And the next division of the solid is solid of revolution. If you take any square or rectangle or any half semicircle and triangle, and if you the round, if you make the revolution about any one of its edge, it will form the solid of revolution. And here we are only majorly concentrating on cylinder and cone. Cylinder we will get when a rectangle is make a revolution about one axis, one edge, then the cylinder will be formed, and this is called as curved surface, and this is called as circumference, and this is the bottom base and this is the top base, and there is a center, an axis. And because we don't have any edges at the curved surface, so we are going to imagine the generator on the curved surface. That generators are the imaginary, the lines which we are considering onto the circumference of the cylinder or of the cone. And the cone consisting one base and then a curved surface, and there is a axis at the center, and there is a slant generator and apex. So if we are triangle, if you are rounding around, revolve about one axis, so it will cover some area. That area, if you make a solid, that is called as a cone. So this cone consisting one apex and axis and a base and then slant generators. And in this projections of solids, we are concentrating these solids used for projections of solids, and these 10 solids we are concentrating for the projections of solids. The first one is triangular prism, square prism, pentagonal prism, hexagonal prism, and then a cylinder. So these all things look like similar because it all having a two bases and then vertical faces, and this will have the vertical curved surface, and these are all pyramids. So the triangular pyramid, square pyramid, pentagonal pyramid, hexagonal pyramid, and then cone. So these 10 solids we need to remember, and whenever some question is asked in the question, if they mention the name of the solid, you need to recollect which solid it is and how edges are there, how many base edges are there, how many vertical face or slant face. So these all things should be remembered. Then the projections of solid will be easy. Projections of solids in simple position. Let us see the first problem. A square pyramid, base edge 30 mm, height 40 mm is resting on its base on the ground, with one of its base edge is parallel to VP. Draw its projections. According to the procedure, we need to first position the solid between the planes of projection. So these are the planes of projection. This is vertical plane, which is in yellow color. It is the horizontal plane, which is in green color. So let me draw a square square pyramid between the plane of projection. So if I draw a square pyramid, so I need to draw on this somewhere. So as a reference, I am taking this point. So I will take this point, and I know the edge length is 30 mm, 30, and the height is 40 mm, 40. So I draw the solid. So this solid I need to first place between the planes of projection. This is vertical plane, this is the horizontal plane. So I will be moving this approximately somewhere here. So in order to see the projections properly, so I will move away from this. So this is the correct position of the solid. So this is a square pyramid. This square pyramid having a square which is resting onto the base, and its height is 40 mm, and this axis is parallel to vertical plane. Now this is the position of the solid according to the problem. So first the procedure is we need to position the solid between the planes of projection. Now we need to start with the view 1. This view 1 may be a top view or front view or side view, but we need to first observe the base of the solid. The base of the solid is parallel to the ground floor, that is horizontal plane. That means this horizontal plane you can able to see in the top view. So you need to start with the top view. So that means you need to first draw the top view. That top view is nothing but a view 1. So from the view 1 we can able to draw the projections and get the front view. Then now let us see how the top view will look like between these planes of projection. Now this is the horizontal, this is the vertical plane, this is the horizontal plane, this is the solid. Now this is a pyramid. This is a square pyramid. So if you want to see how it is looking like in all the directions, so you can able to see, and you can able to see here. So it is how it is appearing in other directions. So it is a square pyramid. But now my job is to see how it is appearing, how it is appearing the top view and the front view. So to see that, what I will do, I need to draw the top view. So I will see the top view. The top view appears like this. Top view appears like this. That means in the top view we can able to see the true shape, and we can also see the apex, and these are slant triangles faces. The slant faces we can able to see. So we can easily draw this top view by assuming this corner point A, B, C and D, and this apex I will be assuming as O. So the top view I can draw. So the top view is like a square and with apex at the center. So now if I want to see the front view and I will first go to the isometric view again, and this is the isometric view. I saw the top view, that is like a square. So when I want to draw the front view will be appearing onto the vertical plane. On the vertical plane I can able to see this triangle, but if you see at the same point the projections, I can draw the projections to the up to vertical plane, and I can able to draw the front view. That means in the top view, once after I get it, so the distance from this end to this edge will be the same. From this end to this edge, the same distance will be there to the point A. So I can easily draw the projections, which is this is the XY line. To the XY line, perpendicular to the XY line, I can draw the projection, and I can locate A and B in the front view, and C and D also on the XY line in the front view. Then the apex I can easily identify because I know the center point. From the center point the height is 40 mm. I can able to locate the apex, and then I can draw the front view. So now if I want to see the front view from here, if I see the front view, so the front view will look like this. So this is the yellow color one is actually the vertical plane, and now this is the front view. So this is the base, and A and B are here, that we will mark it as A dash, B dash, and here the C dash and D dash will be appearing here because the entire base is resting on horizontal plane. Now the apex will be somewhere here, and that is 40 mm from the center point, so I can call it as O dash. So that is how we will draw the projections of solids to this simple position. To solve this first problem in AutoCAD, we will go to documents where we save the previous files, and we will open the template where we will see the layout, and this template first we will edit. So title of the worksheet is projections of solids, and then roll number, and the sheet number we can write worksheet number something like 10, and it is the sheet number 10, and 1 out of something 10, etc. And the date of submission or date of doing the test is today's date. So let me make it 24/9 and the scale is 1:1 and SR University Warangal. So now layout is ready. Then now I will solve first problem. A square pyramid, base edge 30 mm and height 40 mm is resting on its base on the ground. So first I need to draw XY line. So I will take a line and I will draw one horizontal line which is approximately now 50 mm. I will draw one horizontal line. Now the base is resting on a horizontal plane, so I will be seeing the base from the top view. So I will draw the rectangle from the top view and it is having 30 by 30 mm. So 30 mm by the 30 mm. So this is the base, and because it is the square pyramid consisting apex, so apex will be somewhere at the center. So I need to draw the slant edges from the apex. So if I join the slant edges from the apex, it will look like this. So this is the top view, and now I will draw the front view by projecting the lines from the top view. Then the base will be on this XY line, so I will draw one line from this point. And now from here, if you see, there is a axis. The axis height is given like it is given as 40 mm. So 40 mm. So from 40 mm I need to draw this slant edges, so which will complete the front view. But now I need to give the nomenclature. This is like XY line and A, B, C, D, E. So what I will do, as a usual practice, I need to make this diagram. So sometimes projections of solids will take a lot of time only to give the nomenclature and to make the dimensions of the lines, etc. So to make the work easy, what I do, I will make the 3 different lines. So first I will make one line here, that I will make out of the axis line, out of the layout. So the line 1, line 2, the line 3 and line 4. So 4 lines I will make. The first line is for the top view. I will make this in the green color. I will go to quick property. So I will make this in green color. So this color I will change it to green color, and this is I will use only for the top view. And the thickness of the line weight I will make it as 0.5, and this I will use for the top view, and for the front view I will use again 0.5 I will use for the front view, and that I will make it with some other different color, that I will be making with the cyan color. Then there are some projection lines. This I will use this line for the projection line. The thickness of the line will be 0. So projection line is imaginary lines, that is should be 0, and that I will make it with red color. Then the another lines are XY line, that I will keep as it is 0.25, and I need to make the axis line. So this one more line I will write. So this is like the axis line. One more line is, so this is the axis line. So now to change the properties of this line, I need to go here and I will make the center line, and center line properties are not changed here, and I will change the scale as 0.1, and I will see whether it is changing the dimensions. So it is not changed. So I will just change the thickness. Hidden line, axis line will be 0.5 mm or 0.0
1 mm I will make this into the white color, but here I will make the scale to 0.05 mm, and still it is not showing. So I will change the properties. I may change the properties. Instead of changing the properties, I will change the line, the center line. I don't know why it is not changing, but I will just load some other center line. So I will go to load, I will go to center line. So this is the center line, and center line 0.5 or 2x something. So I will be loading the center line 0.5x. So then let me take this center line and then load it, close, OK. Then I wanted to change the properties of this line. That line I will be changing to center line this. Now I will see how the axis is looking like. Oh, sorry, why it is not showing. I am not understanding, but usually it will show. Yeah, now it is showing. So that means the scale is very small. So I need to make little bigger scale. So now let us say this is the suitable scale. So I will, that is why every time when you wanted to change the scale, so it will be very difficult. That is why I will be first making this axis line with one color. So the color also I will change. The color I will change it to yellow, and then the next the thing I will make the line as the dotted line. So I will select this. I will make this line as dotted line. So dotted lines are not here, so go to others. So load the dotted line or hidden line. So we can take as a hidden line. So hidden line is this. So hidden line this, or 5x hidden line you can take. So say OK. So now I want to change the properties of this. So select this and change the type of line, the hidden line, and then change the scale to 5 and check whether you can able to see the dots, and you make it a 10. So then we can clearly able to see the difference. So this color also you will change. This color I will be making into another color, like the green color. Red color is over, so blue color or magenta color I will make. So like this I will be preparing. Instead of magenta color, I will change the color to the white color, or maybe I can go to blue color. So likewise I will make the different colors. So here also I will write the text. So here I will write the text as the text height 5 I am taking. This is for the top view and this is for the front view. So I will come down, front view, and this is like the dimension lines or projection lines, and then this line is for the axis line, and the next line will be the hidden line. So likewise I can write different lines. These all lines I can just keep it. So I will on the ortho. So here this will become a usual practice. Now you may be thinking that it is taken so much of time to only draw these 3-4 lines, but this will minimize in the entire your entire assignment, or in the entire worksheet. This will minimize a lot of time. And also I will also propose you that these all you can keep at one place, and it will be easy. And you need to draw here ABCD. That ABCD also every time if you type it will take time. So you go to text and here ABCD, and I will take the text height 3, and this is A, because in the top view ABCD you will be using, and this is the B, C, D, E, and sometimes F also will come because of a hexagon, F, G, H. These are the things usually you will get it. And then again if you take the text, and you will be taking the A dash for the front view, A dash, and B dash, C dash, D dash, E dash, F, G, H. So these are the F, G, H. So these are for the front view. Again you will be taking the 1 2 3 for the bottom base and top base. So you can take text again. So you can use like 1 2 3 like that. So this becomes a 1 2 3 4 5 6 7 8. Then you can take 1 dash 2 dash 3 dash. So you can write 1 dash 2 dash 3 dash 4 dash 5 dash 6 dash 7 dash 8 dash. So this also you can use. Now again we can also use combination of these two, and the combination of these two also you can write here, and this combination of the things will be helpful. A comma 1, B comma 2, C comma 3, D comma 4, E comma 5, F comma 6, G comma EF, then G comma 7, H comma 8. So this is for the top view. In the similar manner we can also get it for front view. A dash comma 1 dash, and B dash comma 2 dash, C dash comma 3 dash, D dash comma 4 dash, E dash comma 5 dash, F dash comma 6 dash, G dash comma 7 dash, H dash comma 8 dash. So these things you can able to get it. So once now you could have thought that it taken a lot of time, but this will minimize your time a lot. So now these all letters you will be taking every time with you, and here XY line also we will be writing in some other different font. So I will be writing the XY, and I will take 5 mm text height, and here I will write X, and here I will write Y, double enter. So these two I will change the style, and I can change the text style, and I can make it, instead of standard I will go to some other the style. So you can go to any style, but here only I will be going to some other different style of the text. So I will go to the style of the text. I will change some other thing like handwritten text. So any one thing, but all things to be same, the same style. Okay, some other thing I am taking. So close. So now once the xy line is over, so keep the x and y in the proper position. So xy. Now initially now you understood how to draw the top view and the front view. So once after this I need to give the dimensions. So give the dimensions. We already taken the dimension style. So this is 30 mm. So for even in the dimension style you need to go to modify, and the dimension text height you make it the text height you make it only 3 is sufficient, and go to the symbols and arrows. The arrow size you make it 2.5, or only you make it 3 or 2.5. This much is enough, or you make it 3. And then the text alignment, along with the alignment here, and here the lines also will change. The lines, this line type is continuous, and this line is dimension line. The dimension line we will make it 0.5, and instead of white we can make it red, and we can make it some other color, so maybe blue or some other yellow color. So usually this I will keep in white color only, so white color. So the extension lines I will take it in the red color, and the extension line will be 0, 0, 0. So say OK. So I will apply, set current, and close. So now if you see the dimensions, you can able to see clearly, and the dimension lines also you can see. So once after you give the dimension, and here also height you give the dimension. The height is given as the 40 mm, so you give here. So now you see how easy it is. Now this is the top view. What I will do, the top view I need to match the properties of the top view line. So go to the match properties, take a match properties table, select this, and this is the top view. So these all lines are belongs to top view. So select this, so match these properties of these lines. So then this will become the top view. Okay, so the top view match properties. So go to match properties, select this, enter. Oh sorry, oh it's not match properties. Select this, and then impose this match properties to this line, onto these lines, onto this line, because this all belongs to top view. Then you impose this as a front view. So you again you take match properties and match properties table, and then you select this is the front view, and all lines belongs to front view. You make it with this color. Then this is the axis line. So again this is the axis line here. So go to match properties, select the axis line, select this line as a axis line, and this also a axis line, enough. And these are the projection lines. The projection line should be with this color. So again match properties. So go to the projection line. This is the projection line. This line should be projection line. This also should be projection line. So now the entire diagram is over. Now I need to give the nomenclature. So now this I am taking as A, B, C, D. So instead of typing every time, I will take copy paste. So these are the A, B, C, D, E, and A 1, 2, 3 I required. So I will just keep this near to this, and I will just move. So this is A, and this is a B, because the top view. So this is the C, and D, and it is O, apex. So I will be moving here as apex O. So I will select and I will write O. So O I missed actually. O also we can keep it. Then you can draw the front view A dash. So again copy or the move. So this is the A dash. So this is A dash, because in the front view it becomes A dash. Here it becomes a B dash. So this you move here, the B dash, and a C dash here. So this the nearest point you should close, otherwise every time it will be showing here the nearest point. And then finally the O dash. So O dash is here. In the front view it should be O dash. So with this the first problem is completed. So once the first problem is completed, we know that this is belongs to the first problem we need to write the question number also. So draw a small circle here, small circle, and write text here. The text is 1. So now I am taking little bigger text, so I need to keep here, so I will type here 1. So this is the first question answer. It says it is the first question answer. So the first question answer is over. Now let us go to the second question. So likewise we need to draw the projections for the each question, so we can save. So go to the second question. If you go to the second question, let us see the next problem. So second problem says a square pyramid base edge 30 mm, height 40 mm is resting on its base on the ground. Draw its projections if one of its base edge makes an angle 30 degrees to VP. So in this question, the pyramid is resting on the horizontal plane, but one of its base edge, let us say this or maybe other side of this, is making 30 degrees angle with vertical plane. Now it is parallel. This is parallel and this edge is making 90 degrees. So according to this problem, any one of the edge, let us take this, and it is making 30 degrees angle. So first I need to rotate this. So to rotate this, I will rotate this, and I will select this solid, and I will rotate the vertical plane, making angle with vertical plane. I will select this. So then the solid is rotating. So let me select. Then I will give rotation angle as 30 degrees. 30 degrees. So now it is rotated. Now this angle, this edge is making 30 degrees angle. So now how its top view and front view will look like. So if actually it is shaded is given, so let us go to the another type of the view. So let me go to the other view. So it is like, now you see, now you can able to see the edges also. So you can able to easily locate the difference. Now let us see the edges also. Now these are the edges, which this edge is making 30 degrees angle. Now how its top view and front view will look like. So first, which view I need to draw. So if you see the we actually already position the solid between the planes of projection, and now I need to draw top view or front view. So but first I need to observe the base. Base is parallel to horizontal plane. So that horizontal plane I can see in the vertical plane in the top view. So I will first draw top view. The top view will look like this. The top view, if you see, the top view will be looking like this. Sorry. So the top view will look like this. So that means earlier this square, this edge is parallel to vertical plane. So this edge is parallel, but now it is making 30 degrees angle. This is, so with the 30 degrees angle, we will draw one square and we will mark the apex, and then we can able to draw the projections. So once after this A, B, C, D got a new positions, but now if you observe the gap between this edge to this some length, the same length will be appearing in the front view also. So that is why we draw the projection from A, B, C and D, and then we will project the front view. So if you see the front view, if you see the front view will look like this. First we will go to the isometric view, and then we will go to the front view. If you go to the front view will look like this. So front view. So that means this we can able to see two triangles in the front view, and the remaining two triangles are at the back side. So here one more concept is that, so when you see the front view, whatever are there this side, that will be appearing, other side triangles will not appear. So if you go to the top view again, so here one of the concept. So now how to draw the front view. So this is whether A or B. So we need to first mark the A, B, C, D base edges. So this is B. So B to O and C to O, D to O we can able to mark. But where is A? A to O is not visible in the front view. So the A will be appearing somewhere here. So from this point to this point we need to draw the dotted line, because that edge is not visible in the front view. How to identify the the visible and invisible edges. So if you go to the isometric view again, or the top view, if you go to the top view, so if you observe the leftmost corner and rightmost corner, and if you draw a line by joining these two, whatever are there this side, because we are seeing the front view, this all portion will be visible. Other portion, the behind this line, the portion will not be visible. So that means A to O, this position, this edge will not be visible in the front view, so you will be representing with the dotted line. So that is how we can able to draw the projections. So second question says, a square pyramid base edge 30 mm, height 40 mm is resting on its base on the ground. Draw its projection if one of its base edge makes an angle 30 degrees to VP. So this is also a square pyramid. So what you do, you can copy this solution. When you want to draw another diagram, so it is better to copy this existing solution. So copy this, and somewhere you paste here conveniently. Then this is the question number, you can change it to 2. Then here the only change is, here it is also 30 mm, the height also 40 mm, but this top view is making 30 degrees angle. One of its base on the ground, and base edge is making 30 degrees angle. Now it is making parallel, it is parallel, so you need to make it 30 degrees angle. So what I will do, the front view, everything I will delete. So instead of keeping, I will delete this. The XY line I will keep. So this projection lines also I will delete for the time being. So rotate, I will be rotating this to 30 degrees. So now it is parallel, so I will be rotating with 30 degrees. So now I will move the top view with convenient distance, so that it will be easy for drawing the projections. So now this XY line is, I will extend. So I will further move the Y some distance till here. So now we will draw front view. So now the top view is same, because already making 30 degrees angle. So that 30 degrees angle I can also give here the angle. So angle between these two lines is 30 degrees. So 30 degrees angle also I am mentioning here. Now I will draw the projections. So if you draw the projections from A, B, C, D, this is from A, and this is from B. So I can on ortho when you draw the projections. So from the center line, and again from D, and from C. So we will be drawing the projections. So again height is given, which is 40 mm height. Now if you see, this 40 mm is the axis. Then if I see the front view, so the front view, always when you want to see, you need to first draw the faces which are visible. So if you see the front view from this side, so this face will appear and this face also will appear. So that means the B to O will be appearing. So that means B will be somewhere here and B to O will be appearing. So I will draw the B to O, and then I will draw a line one more from D to O. So D to O also I will draw line. So D to O will appear. So then I will also one more line will appear, that is C to O, and C to O is this. And one more the visible A to O is not visible, but still I will draw the line. And now I will give the nomenclature. So now I already given top view, the front view I need to give. So I will copy this the lines, and I will keep here O dash already there, and A dash. So I will just move. So where is A? So A is here. So A is here, it's a dash. Then this is a B dash. Here is a B dash. The O snap I will off, because O snap sometimes the nearest point will make disturbance. So I will be intersection point also will make disturbance sometime, but I will just close this. So B dash, then the C dash will be here, so copy, C will be, C dash will be here, and D dash is here, and the remaining things is O dash. So now the projection of points is over, projection of this solid is over. Now I need to make the lines. So now if I match the properties MA, if you type instead of every time clicking there MA and enter, so the first, this is the front view, the front view will be with this color. So this is the front view, hidden line, visible line, and this is also visible line. One more line will be visible, which is at the down. So I will draw a line first, and then I will do the match properties. Go to match properties MA and project this line, and this is the axis line. So again you take this axis line, this is the axis line, so select this, and this should be a axis line instead of projection line, and then these all the projection lines. So again match the properties, this is the hidden, the projection line. So this is the projection line, all red color things are projection lines. So even this is also a projection line till there. Then later this is the hidden line, because AO will not be visible. So the hidden line, you will be taking the blue color. So match the properties to hidden line. So hidden lines, match properties. So take this hidden line. So select this. So now it is changing. No, it is not changing. So sorry. Again match properties. Select this and impose the properties to this. So with this, the front view and top view of this second problem also over. So now this is the solution for the second problem. Let us see third question. A pentagonal prism having base edge 25 mm and 40 mm height is resting on one of its base on the ground with one of its vertical face parallel to VP. Draw its projections. So we need to first draw the prism. This is the hexagonal prism. So to draw the hexagonal prism, we will go to we can't actually directly draw the hexagonal prism, so we will go to it is pentagonal prism. So we will take a polygon, and the polygon base will be number of sides will be 5, and then we will take the edge, and let me mark the edge here, and the edge length is given as 25 mm. Enter, and the height is given. So we will go to extrude and extrude this, the polygon, and the height is given as 40 mm. So this is the given solid, and this solid we need to position between the planes of projection according to the problem. According to the problem, it says it is resting on one of its base on the ground with one of its vertical face parallel to VP. So now I am considering this is the vertical face which is parallel to VP, so I can keep as it is, but this base is resting on this horizontal plane. So I will just locate this suitably. So suitably onto this the horizontal plane, because it is resting onto the horizontal plane, and then I will be rotating, I will be moving little away from here. So this is how the solid is positioned. So it is resting on the horizontal plane, this base, and this face, vertical face, is parallel to vertical plane, VP. So now we need to draw the projection. So first we position the solid, then we need to start which view, whether top view or front view. So it is parallel to horizontal plane. We will start with the top view, where we can able to see this true shape of the base. So then if you see the top view, if you see the top view from here, so the top view will appear like this. So see here, this is the top view, and like a regular the pentagon it will be appearing. So then we can able to easily draw, and we will mark A, B, C, D and E, and this A, B, C, D, E are the bottom base. But what about the top base? That means there are two bases, so the top base will be marked as 1, 2, 3, 4 and 5, and both ways are correct only if you mark one A, B, C, D to top base, and 1, 2, 3, 4 for the bottom base, both are correct. But here, because there are two bases, The bottom base we are calling as ABCD and top base we are calling as 1 2 3 4. So then we can able to locate all the corners with the numbers. Then we draw the top view first. In this top view we can able to see this is A, let us say this is 1 and this is A. These two will appear at the same place. So this point in the top view will be called as A comma 1 and this point in the top view will called as B comma 2. So likewise we can able to see, and if you see the top view, it is only one, the base is appearing, that is the top base, and the bottom base is hidden. But the top base and the bottom base edges are coinciding, so we can't draw the hidden lines. So now this is the top view, and to get the front view, again we will draw the projection from each and every point to the front view, and then we can able to draw the front view also. So if you go to isometric view, then this is the isometric view, and if you see the front view, we can able to see this rectangle face and this face and this face, and other two faces will not be visible. As I already told you, leftmost corner and rightmost corner point if you take and if you draw a line, so whatever the portion this side, that will be visible, and other side of the solid will not be visible. So this edge, that is 5E, will not be visible in the front view. So that edge we will be calling, or we will be marking as hidden line. So then if you go to the front view, the front view will appear like this. The front view will be appearing like this. So this is A, B, C, D, and E will be back side. So that is actually coinciding with the axis also. But when it is coinciding with the axis, we will only give the priority to the hidden line, which is dotted line. So that is how we will draw the projections of the solid in this simple position. So third question, a pentagonal prism having a base edge 25 mm, 40 mm height is resting on one of its base on the ground with one of its vertical face parallel to the VP. Draw its projections. Now to make it simple, you will again copy only XY line. So because remaining all things are different here, so we will copy only XY line and comfortably we will keep somewhere here, and then we will delete these lines also. So now we need to first start with the top view, because the pentagonal prism is base is resting on horizontal plane. So we will be starting with the top view. Then take a pentagonal prism. So if you take the top view, we need to first draw a polygon. The polygon number of edges are 5, and base edge is given. The base edge is given as 25 mm. So you select this line and then you go to ortho, then the 25 mm is given. So 25 mm, 25, so enter. Then this vertical face is parallel to vertical plane. This vertical face is parallel to vertical plane. Now this is the final, this is the top view. Then I need to draw the front view. So from the top view, so now I will give the nomenclature later. So but I will be drawing the projections from each and every the point to onto the XY line. So if I draw, then this is the axis line, but this axis line, this is having 40 mm height, 40 mm height. Then because it is also having a base edge, the base edge will be base edge and top base edge, bottom base edge will be there. So I will be moving the top base edge here. Then I can draw a line from here. This is the vertical face, one more vertical face. And now if I draw everything, so this becomes the front view. This will become the front view. So in this I will first give the dimensions. The dimensions I will take it. So dimensions is given as 25 mm here, and the height is given as 40 mm. Then I need to make the match properties. Go to match properties. This is the projection lines. These are the projection lines, and then this is the front view. Oh, sorry. So these are the the projection lines. So select this line, the match properties, then you go to the match properties, then select this, then match properties, select this top view or front view, and select all these lines, and select this line also. This is also a front view, and then the top view. This is the match properties again, and these are the projection lines. The projection lines again, match properties. This is the top view. This will be the top view. So now in the top view there won't be any hidden lines because it is in simple position, but in the front view, if you see, this is edge, this edge is hidden, so we need to draw this hidden line with the this hidden line blue color, and the axis will not be visible. Now the hidden line and axis both are coinciding. These two, when it is coinciding, we will first give priority for the hidden line only. So here instead we can actually see, keep these lines in a sequence. The hidden line is the next the ranking after the front view, top view, then axis line, and after axis line the least priority we will be giving for the projection line. So that means whenever these two are coinciding, we give first priority for the hidden line only. When the hidden line and is matching with the visible line, so visible line only we will be giving the priority. So likewise we will be seeing. So this will be the final the diagram. So now here I need to give the nomenclature. So I will bring this the letters here. I will bring the near to the diagram, so it becomes easy to draw the write the text. So I will move the text. So this is like A, approximately near to. So now this is not the diagram, the things I need to bring here. I need to bring these letters. So because the top view, so both bottom base and top base will be there. So when the bottom base and top base are there, so better you bring these letters, so it becomes very easy for you to the type. So you go to again move. So here this becomes A1, this becomes B2, and C3, and D4, and E5, etc. So bottom base A, B, C, D are the bottom base, 1, 2, 3, 4, 5 are the top base. Now in the similar manner I will go to the front view. So in the front view, A, B, C, D will be down, and 1, 2, 3 will be in the other side, so there won't be any confusion. So 1, 2, 3 and A2, this will be separate. So here I will take these letters, copy, I will place somewhere here. So here, so A, B, C, D will be the bottom base. I will move. So this will be the A, this will be the A dash, and B dash is here. This is the B dash, then the C dash will be here, then D dash, E dash will be here, and this is over. Then I will be seeing with the 1, 2, 3 dash. So now if I take A dash, this will become the 1 dash, this is the 2 dash, 3 dash, this is the 4 dash, the 5 dash. So these are the nomenclature. So with now, because of these letters, it is taking so much of very less time. Otherwise every time if you are typing, it will take a lot of time. So this will be the solution for the third question. So here I need to give the question number also. I will be copying this and I will change the question number to 3. So with this I completed the solution for the third question. Now we will go to the fourth question. Fourth problem. A hexagonal prism, base edge 20 mm and height 40 mm is resting on one of its rectangular faces on the ground, base being parallel to VP. Draw its projections if the base is 10 mm in front of VP. So first we need to draw hexagonal prism. So if I draw hexagonal prism here, and this hexagonal prism base is resting on vertical plane. Now the rectangular face, that means other rectangular face, that is resting on horizontal plane. So then I will be moving this solid here. Then I can able to see this face is parallel to horizontal plane and this base is parallel to resting on vertical plane, and it is also 10 mm away from horizontal plane. Then if I move this 10 mm, so this is the exact position of the solid. So with this position I need to draw the views. Now if you carefully observe the base is parallel to vertical plane. When the base is parallel to vertical plane, I need to first start the view in which we can able to see the base. That means in the front view only we can able to see the base. So we start with the base, that is the view 1. So if you see the view 1 of this solid, the view 1 will appear like this. So view 1 in the front view will appear like this. It is like a regular hexagon. So then we can mark A, B, C, D, E, F, which is the bottom base, and 1, 2, 3, 4, 5 and 6 are the top base. Then that we can able to mark in the front view. Then you draw the projections to the top view, and then we project the top view. So if you see, if you go back to isometric view, the isometric view will look like this. Then you go to the top view, and if you see the top view will appear like this, and this is the bottom base and this is the top base. So let us say this is A, B, C, D and E, F, and this is 1, 2, 3, 4, 5 and 6. So that is how we can able to draw the projections of this simple solid. So here they also mentioned this is 10 mm in front of vertical plane. So this gap we need to maintain with the given dimensions. Earlier they have not given how much far the solid is from the vertical plane, that is not given, but here in this solid they given this dimension, so we need to follow this. To start fourth question, I need one more layout. So I will copy this layout. So first I will copy this layout. So take copy command. So copy command, and this entire layout I will copy and I will keep next to it, just next to it. So then this will become the second worksheet. So this becomes worksheet number 10 and 2 out of 10. 2 out of 10. So this becomes a second worksheet, second sheet out of 10 in the worksheet number 2, worksheet number 10. So now I want to draw the projections of the solid for the fourth problem. So now if I will copy XY line and Y also I will copy, and I will keep comfortably somewhere here. So now I need to see I need to read the problem. So hexagonal prism, the vertical face is resting on the ground. So I need to take a hexagon, the hexagonal prism, and the number of sides are hexagon, so 6, and edge length is given, and edge length is given like it is the 20 mm. So I will on, and it is 20 mm, so 20. So now I will move, because this base edge is resting on horizontal plane. So vertical face is resting on horizontal plane. So this is how it will look like in the front view. So if I draw the top view, so they also says that this is making 10 mm from VP. So and again height is 40 mm. So now again you can take from here, so up to XY line 10 mm and then 40 mm, and this is the base. So again here if I draw this will become the top view, draw the projections, and here is the axis line, and this axis line I directly draw, and here I will see another top view of this. So with this I can able to complete the third diagram. So but before I complete, I give the dimension. So this is the 40 mm dimensions, and they given the base edge dimensions as 20 mm, and then I need to give the nomenclature. So before that I will also always copy these edges, or I will be just copying these edges. For copying it will not take much time, it is not we draw every time, so we just copy and keep here. It becomes very easy for other diagrams, we can use these things. So now I will be using this for the match properties, and the top view I will be coinciding with this. So the select these all lines, these are belongs to top view, the top view, and then this is the axis line, so match the properties. So go to the top view, front view. So this is the front view, so you take front view of the line and match it, match properties. This axis line we are not axis line, match properties, axis line, this is the axis line. So then these are the projection lines, so you can take the projection lines, match properties, all red color, you need to make it the projection lines with the red color. So here red color, and here also red color, and this is also red color because this is also a projection line. So this will complete the drawing 4. So we need to keep the question number also. So always you keep question number here, so this becomes a 4. So now I need to give the nomenclature, or I need to give the notations for every corner. So if I take the notation somewhere I can keep, because 3 I need to keep. So now A, B, C, D. So now again I will keep these things. So I will bring for the front view, I will bring this A, B, C, D. So because here the both the bottom base, top base is coinciding here, so I can move 1 dash, A dash here. This is A like A, and this is like a B, and it is the C, because both bottom base, top base will be appearing here. And then D, E, and F. Then top view we will get it. The top view we can easily get from these diagrams. So copy this notations, you keep the notations here. And now these notations will confuse, so we will bring these notations only, separate notations, because in the top view there won't be any dashes. So I will keep these notations here. So move the notations. So let us say A, B, C, D will be taken here. So this is 1, so move. So this is like 1, and it is 2, and this is 3, and another one is 4, and here there is one more edge, so that will be 1, 2, 3, 4, and there will be a 5 and 6, and there will be a 5 at this place, and a 6 is at this place. So these are the 1, 2, 3, and A, B, C, D. If you see, this becomes A, this corner is A, this corner is B, and another corner is C, D, E, F. So likewise, if you have these notations, it will be very easy. So now I completed the fourth unit. I completed fourth. The fifth question. A right circular cylinder diameter 40 mm and height 50 mm is resting on its base on the ground. Draw the projections. Now we need to first draw the cylinder here. So if I draw cylinder, this is the cylinder which is resting, the base of the cylinder is resting on horizontal plane. So I will be moving the base here, and also given the axis they did not given, but it is resting on its base on the ground. So we need to draw the projection. So here the cylinder will not have the edges, but we will be assuming the generators on the circumference of the on this curved surface. So then that generators we will be calling as A, B, C, D and 1, 2, 3 in the top and bottom base. Then we can able to draw the projection. So now let us see the top view. Now even cylinder, the base is parallel to horizontal plane. So we need to first start with the top view. And if you go to the top view will look like this. So if you see the top view will be appearing like a circle. So this circle circumference we will be dividing into the 8 divisions. In AutoCAD, if you want to draw, it is 8 divisions is sufficient. Sometimes if it is only simple position, 4 points also is sufficient. So as of now we are doing only simple position, we draw only 4 divisions of this. So this becomes A, B, C, D and 1, 2, 3, 4, and the top view it appears like a circle. And if you see the front view will appear like a like a rectangle. So if you see the front view will appear like a rectangle. So here again we can mark the same points and we can draw a rectangle from the top view which we have drawn the circle. So that is how we will complete the projections of this cylinder. Fifth question is a cylinder resting on horizontal plane, and its base diameter is 40 mm and height is 50 mm. So let us draw the projections of this solid. So now if you copy, now let me copy this XY line, or otherwise some of the important things which I required. So now this entire top view I am just deleting, and the front view also I am deleting. So now I will take the cylinder. Cylinder is having the diameter 40 mm. So I will it is resting on horizontal plane. So I need to first start with the top view. The top view is a circle. Radius is the diameter is 40 mm. Now you keep the cylinder with the comfortable distance. Then you draw the projections. If you draw the projections, so here how many projections I need to draw? Because if I take the projection lines, so I need to consider the 4 points. 1, 2, 3, 4 is enough for cylinder. So I can in AutoCAD, so then I can go to the height is 50 mm. So then this will become the bottom base, and if you go to the top base, this will become the top base. Now you draw a line starting from here. So always for the cylinder we need to draw the axis. Now you match the properties. These are the projection lines. This is the axis line. So match the properties. This is axis line, and this is the front view. So if you take the front view, this is the front view. And then the top view, if you match the properties for the top view, this will be the top view. So circle will be the top. Now let us give the nomenclatures. So now let us copy the nomenclatures here. So if I keep here, this becomes the, this I will draw here. This is a dash a comma 1, this is b2, this is c3, d4. Some people, they will be equally dividing into 8 divisions the circumference, but here I am only dividing the circumference into only 4 divisions. And again the front view, it will be a dash b dash like that. So I will bring this the notations. So now the move. So now this is a, so a dash will be coming here, and b dash will be here, and c dash will be here, and d dash will go here again. And again 1 2 3, one dash here, two dash here, 3 dash, and it is 4 dash. So with this, it is completing the projections, because if you divide the circumference into more divisions, it will take time, otherwise it is not taking that much time. Sixth question, a pentagonal prism having base at 25 mm and height 50 mm is resting on one of its face on the ground with the axis perpendicular to VP. Draw its projections. Now first we need to draw a pentagon. So pentagon we will draw. So I will be drawing here. Number of sides are 5, and I will take the pentagon here. Number of sides are 5. Edge length I know. Then I draw the pentagonal prism like this. So it is 25 mm. So 25, enter. Then I will draw the projection. I will use the extrude command, and I will draw the height. Height is 50 mm. Enter. Now I will be moving this to the exact location. So it is resting on the horizontal plane. So first I will move these two on this plane somewhere to the corner. Then I can easily move to the location between the planes of projection. So if I move this solid approximately onto the between the planes of projection, so it will be looking like this. So now this distance they have not given, so I am just making the axis parallel to horizontal plane, and this axis is perpendicular to vertical plane. Then in this position I need to draw the projections of the pentagonal prism. So now if I see the front view will look like this, and it is so I need to first start with front view or top view. So if you see properly, so the base is parallel to VP, so we need to draw the front view first. So if you go to the front view appears like a regular pentagon, and then you can able to draw the front view by marking the pentagon and its corner points. Then you can go to the top view. So if you go to the top view will look like this. So you can go to top view. So before that we will go to the isometric view. So in the isometric view, I already told you find out a point, leftmost corner point and the rightmost corner point, draw a line, and if it is top view, so whatever is there above the line joining these two left and rightmost corner points, that planes will be visible, that surface will be visible, other surface will not be visible. So when you go to the top view, this plane and this plane will be visible, and other three planes will not be visible. That means there is one edge, that is B22 and C23 will not be visible in top view. So if you see the top view now, the top view will appear like this. So this plane and this plane will be visible, and other two planes will not be visible. So there will be a hidden line here, as well as here, these two becomes the two hidden lines. So with that we can able to draw the solid. Seventh question, it is similar to fifth one. A pentagonal prism having base edge 25 mm and height 50 mm is resting on one of its vertical edges on the ground with the axis perpendicular to VP and the opposite face is parallel to the ground. Draw projections of solids. So this is also a pentagonal the prism, but only thing is this base edge, this face, vertical face is parallel to horizontal plane, but this base edge is resting on horizontal plane. So then I need to rotate this in such a way that this vertical edge will be resting on a horizontal plane. So then I will go to the rotate, I will select this and I need to rotate it to 180 degrees. So if I click this and I will be rotating this to 180 degrees, then it is properly rotating. Now if you see, this base edge is resting on the horizontal plane and this is also a parallel to the ground, and we can able to see everything. Now I think if you let me check the front view, yeah, it is exactly resting. So we can able to see the front view will look like this. The front view will look like this. So that means this let us give the corner points A, B, C, D, and then we can able to draw the front view first, because it is base is parallel to VP, and then you draw the projections and draw the top view. The top view will be looking like this. The top view will be looking, because if you see the top view again, now these three faces will be visible, and the remaining two faces which are down will not be visible. So this line joining the leftmost corner and rightmost corner, the top face will be visible and the bottom face will not be visible. So then we can able to draw the top view. The top view will be looking like this. So next question. So this is actually a fifth question answer. So next I am solving the seventh question. So remaining things we can practice. So this is, I will be copying only XY line. So I will keep XY line here. Now a pentagonal prism having base edge 25 mm, height 40 mm, the height is 40 mm, height is 50 mm, is resting on its base edge on the ground. So I will take first the pentagonal prism, and the number of edges are 5, and take the edge length. The edge length is given as, so I will on ortho, so edge length is given as 25 mm. So now this I need to rotate, because the base edge, this edge is resting on the ground. So rotate this, and 180 degrees, and then move this onto the ground, to the base point. So this becomes the front view. Now you draw the projections from each and every point onto the plane of XY line. Then draw the axis is 50 mm. Now you draw a line from here to here. Axis is 50 mm, so 50 mm we will make it little away from the XY line. So from here I will take 50 mm. So then you take a line from here to here, move this line from this point to this point. You again copy this line here, then you draw a line from here to here, and then remaining things. So draw lines. So with this the drafting is over. Now I need to first give the dimensions. This is 50 mm is given, and you can give the dimension, and here these dimensions are given as 25 mm, so give the 25 mm. Now I need to change the properties. So the change the properties, match properties. So match properties, all the hidden lines and the axis line. So this all things is making our work easy. Now this is the axis line, so match properties to axis line, and I am not matching with the axis line because the axis line also there from the center and hidden line also there at the center. So this becomes the hidden line, and then again the top view should be with the front view should be with this line, with this properties, and the top view should be with this properties. So I select all the lines which are belongs to the top view with the solid line. So these are the solid lines, and this line is not visible, so that will be at the bottom. So that I have given with the hidden line. Now I can just bring the notations. So A, B, C, D, I will bring these notations. Then we will move. So this is A dash, 1 dash, this is a 2 dash, 3 dash, and this is a 3 dash, 4 dash, and E dash, 5 dash, and this is over. And again, if you see the top view, in the top view A, B, C, D will come. So you bring this A, B, C, D and 1, 2, 3, and here if you bring this, I can give I can consider anything. So move, I can consider the A, B, C, D here, or maybe there also. So this is A, so this edge is A, and B, this is a B, and C, and it is D, and it is E, and this I will make it as 1, 2, 3. This is 1, 2 will come here, 3, C, A, B should be here. So here it should be B, and here it is C3, and 4 will be at D, at 5 will be here. So with this nomenclature also over. So likewise, and this is a question number 7. So I am not actually explaining all the diagrams. So remaining things you can practice, and this is I made here, I just wanted to make the concept of hidden line. So here this I am saying the hidden line, because when I see the top view, so these all faces will be visible, but these two faces will not be visible. So these two faces are covered by these edges, and out of 4 edges, this only one edge will not be visible, that is B dash 2 dash in the top view. So that is why it is made a dotted line. So again here also it is reverse case, we are seeing the front view, so this will be the hidden line. So these hidden lines are very, very important in case of when the solid is inclined to any one plane. 8th question. A square pyramid base edge 30 mm and height 40 mm is resting on its base edge on the ground, and its axis perpendicular to VP. Draw its projections. First I need to draw a pyramid, square pyramid. So to draw the square pyramid, I will take square pyramid, and I will usually I will draw here. The square pyramid base is 30 mm, 30, height is 40 mm, and this is rotated, and this base edge is resting on horizontal plane, but this is axis is perpendicular to vertical plane. So that means I need to rotate this to 90 degrees. So now I need to rotate this way. So then if I need to rotate it to 90 degrees. So then I need to rest this base edge on horizontal plane. So what I will do, I will move this corner point to approximately somewhere to this midpoint. Then I can easily rotate or move whichever the way I want. Then I can move here approximately. So now this is the position of the solid. Now if I see the front view, now I need to, as I know the base is parallel to vertical plane, I need to start with the front view. If I see the front view will be appearing like this, like a square, and this is the apex, and I will mark the points. Then from the front view I can able to mark the top view. So if I go to the top view is like a triangle with some distance from the vertical plane I will take in order to make convenient for for the projections. So this is how it will look like in the top. So ninth question, a pentagonal pyramid, base edge 25 mm, height 40 mm is resting on its base on VP and one of its base edge is parallel to HP. Draw its projections. So here it is the pentagonal pyramid. So when you already draw a square pyramid, it is very easy to draw the pentagonal pyramid. So now first you click on this, it will ask number of sides are 5, you enter. So then it becomes a pentagonal pyramid. Now the pentagonal pyramid base is, this base is resting on horizontal plane and the base edge is resting on its base on VP and one of its base edge is parallel to horizontal plane. So this base is resting on vertical plane. So in order to exactly locate the base onto this on the vertical plane, I will move the base and this base edge I will take and I will be placing here onto the midpoint. Then I can comfortably move onto the same the plane. So then I will move the solid here, and now this is the pentagonal pyramid which is resting on vertical plane. Now I can see the front view, because in the front view I can able to see the base with a true shape. So if I go to the front view will appear like this. Front view will be appearing like this. It is like a regular pentagon. Then I can see the top view. If I go to the top view, so the top view will appear. So in the top view also I can able to see only these two faces, and other three faces cannot be visible, and that I can mark there. So in the top view, so if you see the top view, only these two faces are visible, another three faces are not visible. That is marked by the dotted lines. Last question. A right circular cone diameter 40 mm and height 50 mm is resting on its base on VP and its axis is 40 mm above horizontal plane. Draw its projections. First I need to draw cone. So take a cone, and a cone base is resting on this plane. So I can't able to rotate. So I will take the cone here. First the cone diameter is 40 mm, so radius will be 20 mm and the height is 50 mm. So this is the cone. This I will rotate to 90 degrees. So if I rotate 90 degrees, it will be rotated like this. Then I will move this base should be resting on vertical plane. I will move this base such that the base is resting on vertical plane. So if I move like this, so it is resting on vertical plane. So now I can able to draw front view or top view. Again base is parallel to vertical plane, so I will be drawing front view. So if you see the front view will be appearing like this. It is like a circle. So here also I will take 4 corner points A, B, C, D, and apex is O. Then I will draw the top view. So from the front view I can able to project the top view. So if you want to see, you can carefully see, observe how the top view is looking like. It is like a triangle. Projections of solids inclined to one plane. First question. A square pyramid, base edge 30 mm, height 50 mm is resting on a base edge on the ground. Its axis is inclined 45 degrees to HP and the axis is parallel to VP. Draw its projections. So first, with the given position of the solid, we can't draw directly front view and top view. So first we will locate the solid in the simple position and then rotate the solid with the required angle to make the axis inclined to 45 degrees to HP. So first we will draw the square pyramid. So we will draw the square pyramid. So square pyramid I am drawing here. The edge length is given as 30 mm and the height is given as 50 mm. So this is the required the square pyramid. So I will first, initially the final position is like this. Final position, this axis is making 45 degrees in angle to horizontal plane. So first in order to get the final position, I need to first draw the projection of this projection of this solid with the simple position. So this is the first position, the simple position. Now in the next position I can rotate this. So as usually, first you place the solid with this simple position, draw top view first and then draw the front view. So the top view and front view you can draw how you draw in simple position. Now you need to rotate the solid. So I will be copying this solid for the second position, second step. So then I need to rotate this solid to 45 degrees in such a way that this is making some angle 45 degrees to horizontal plane. So I will rotate this in such a way that it will make 45 degrees minus 45. Sorry, it's rotating. So I will be rotating this in such a way that it will make 45 degrees angle. So if you see, it is rotated 45 degrees angle this side. So this base is still resting on horizontal plane. So I need to make this solid in such a way that it should rest on the horizontal plane. Usually this should be rotated in the other direction like this. So now it is 45 degrees and this base edge is still resting on horizontal plane. So first I will locate this properly, then I will move this and I will place such that it is resting on horizontal plane. Now if you carefully observe, now I will go to the front view. So first you will be drawing the top view, then you will be projecting the front view of the first stage. Then what should you do? So this is the front view, that is my second view. So first view will be a square and second view is like a triangle and third view will be this. So that means in order to get this view, what you are making, the axis you are making 45 degrees angle with the horizontal plane. When you rotate this solid to the required the angle. So this solid is making the 45 degrees angle with the horizontal plane. At that time, if you observe the front view of these two solids, front view of these two positions, so the shape of this solid is same, but only thing is the front view is just rotated with 45 degrees and the shape is not changed, only the angle is changed. So that is why when you draw the second view, if you rotate it to get if you rotate it with the required angle, you will get the third view. So that means we will not do anything, this only we will copy and then we will rotate it to required angle, and then we can able to draw the projections, and then we will get the next view, that is the fourth view, by combining the top view and the front view and top view of these two, view 3 and view 1, and we can able to get the. And now if you go to for example, if you want to see the final top view and of this solid, so if you go to the top view, how it is appearing, you see. So generally these two will be on the same, because I just randomly moved, so I can even move now. So this should be on the same the plane, so it should be on the same plane like this, and it should also be moved here comfortably. So now if you see the final top view, because the top view is changing its shape, this four faces I can able, 3 faces I can able to see, and another face which is bottom cannot able to see. And here this the final top view is making the tremendous change in the top view. This is the set view 1 and this is the view 4. To get view 4, I will be first drawing the projection from A, B, C and D parallel to the XY line, and even from the apex parallel to the XY line. But with the rotated view in the front view, from the front view, so from this A, B, C, D and apex I will be drawing the projections. Then I can finally able to get this the points A, B, C and D and apex, I can able to draw the projections. Whenever you wanted to draw the final view, you first mark all the outside, the corners, edges with the dotted with the solid line. Then you see in the top view, I already told you, so we can go to the front view, and now we need to draw the top view. So when you want to draw the top view, you take the leftmost corner and rightmost corner and draw a line. So that means all the faces above this will be visible. So then you can go to the front view and the top view. So this face will be visible, and all the corner, all the outside edges will be visible. So you can mark all the outside edges, and this triangle also will be visible. Then what is not visible, which is below the line, that is this edge is not visible. So this is a C and D, so CD will be represented with the dotted line. So this is how it will be appearing in the final, the view 4. So let us solve this first question in AutoCAD. So now I want one more layout, so I will copy this layout. So I will place next to it, and here whatever is not required, that I will delete. So projections of solids, and this worksheet number I will make like 3 by 10, and the remaining things I will keep as it is. So now I am solving the another problem, first problem, so which is here, this is actually 5. So now according to the problem says a square pyramid, base edge 30 mm and height 50 mm is resting on its base edge on the ground. Its axis is inclined 45 degrees to horizontal plane, and axis is parallel to VP. Draw its projection. So first if I see if I draw, I will first draw XY line. So instead I can copy XY line from here. Now because this problem I can't solve in one step, I need to solve this in 2 steps. So I will increase the XY line, the distance. I will increase the length here till here. I will extend this. Then I will draw the first stage here. So now the base is parallel to horizontal plane, so I need to start with the top view. So I will take a rectangle, so which is the 30 by 30, and because it is the pyramid, so it will have apex. So I will be drawing apex from this corner to this corner, and this is the apex. So this is the top view. So now I will get the front view by projecting the top view. So width I will get from projecting these 2 points, and this is the base. And to get the height, this is the projection line, height is 40 mm. So let me check, height is 50 mm, sorry. So height is 50 mm. So now you connect these 2 points to make the slant edges. Now with this, the front view of the first stage is over. Now to get the second stage, so I can copy this and go to the second stage, but before that I want to actually give the notations. Before that I will give the dimensions also for this, because again I need to, when I copy this, all the notations and dimensions will come along with the, and you also know these all things will, once if you copy, it will minimize our time when you draw another diagram. So better I will copy and keep here. And now I want to keep the notations, or first I will match the properties. So match the properties, the top view will be in this color, so top view, and these lines should be same, and this is the front view, so match the color. So this is the front view, and the top view you can match the properties of front view. The front view is this line, and one more base line is the front view. And then you go to axis line, match the properties of axis line. So this is the axis line, and these 3 are the projection lines. So match the properties of the projection line. So then you given the dimensions also, but give the notations. Notations are A, B, C, D, and so copy these notations, you can copy and keep here. I will now, when you are copying the notations, you better off the ortho. Now this becomes A, B, C, D. So move, this is A, this is the B, C, D, and this is O, because top view it is O, apex. And the front view, for the front view I will bring these notations again here. This I don't require it. So again let me move, this is A dash, B dash, C dash, and D dash, and apex is here. Apex you can move here, this is O dash. So but if you give the notations once here, the advantage is for the second step we need not to waste our time to give the notation separately. So now what is happening, now I need to rotate the front view. I need to rotate the front view because the axis is making 45 degrees angle, axis now it is making 90 degrees angle. When you are making angle with the horizontal plane, so that angle can be visible in the front view, and the shape will not change when you are rotating and making the axis inclined to horizontal plane. So but the axis is parallel to vertical plane. When the axis is parallel to vertical plane and this axis you are making inclined with the horizontal plane, So the front view will not change its shape. So you copy this front view and copy and paste here. Now you on ortho. Now we need to rotate. We need to rotate it in such a way that the axis will make 45 degrees angle with the horizontal plane. Now this height you can remove. You rotate the front view in such a way that axis make 45 degrees. So take rotate command, and now this edge, the base edge CD is resting onto the horizontal plane and axis is making 45 degrees angle. So I am giving the base point for rotation as this point, and then the rotation angle I am giving as minus 45 degrees because I need to rotate in clockwise direction. Finally I need to get this view. This is the view 1, this is the view 2. View 2 we got it by projecting from the view 1, and view 3 is only the simple rotation of the front view, and final the top view we will be getting by projecting from the view 3 and view 1. Now let me draw the projection line from ABCD, and apex, and these are the from the front view projections. Now let me get the projection from the top view. So this is A up to here, this is a B up to here, and this is a C also will go here till here. And then if you see the apex will be going till here. These all lines are projection lines. So now I will change the properties of these lines as the projection lines. Then I need to draw the top view. So when I want to draw the top view, first when I see from the top view, as I already explained, when you draw a line from leftmost corner to rightmost corner, whatever the above faces will be visible in the top view. So now ABO will be visible. So now this is the notation of A plus A dash, so this becomes a A. So now I will draw a line from A to B and B to O, and O to again coming back to A. So this triangle you can able to see, and another triangle I can see is, and all outermost edges. So that means this is a C and this is a C dash, so this will join at C. So this is the C. There is a base edge one more BC, otherwise I can even give the notations. So I will give the notations. So this is C, this is a B, sorry, this is A, this is the B, notation of B, and this is the notation of C, this is the notation of D, and finally this is the apex, this is the apex O. So now ABC, ABO is the first topmost triangle which is visible, and one more triangle that is all outside. First when I want to identify the hidden edges, hidden lines, I need to first draw a solid line to all the outermost edges. The outermost edges are here. Outermost edges here are, so AD is the outermost edge, DO is the another outermost edge, and OC is the another edge, and CB is the another edge. Then I can see these all edges are visible, but only one edge which is a CD is not visible. So it's here already there is a projection line, so I need to delete this projection line. So better I will trim here, and this up to here only required the apex. So this I will trim because there is a axis line will come, and this much projection not required, so I will be erasing. So this all things I will be erasing. So this will become the top view, and there is one more line which is the CD, but CD will not be visible in the top view, but this is an invisible edge, so this should be a invisible edge. So now we will match the properties and we will change the line as invisible edge like this. invisible edge, and there will be an axis here. So this axis also I will change from the apex O. So this the properties again I will change. So go to axis properties and match the properties to axis properties to this line. So with this the top view of this problem also completed. So this will become this is become a 2 stages problem. So now if you want to reduce the length of this line, you can even reduce. So you can move here till here, then you can trim it. You can trim these lines. Now this is the problem, and even you can reduce this size also, because the 2 problems we can able to accommodate over here. So if otherwise, if you are submitting only online submissions, so this you need not to trim, and one sheet we can make one problem. And if you feel one more problem you wanted to accommodate, if you want to take a printout, and you can accommodate. So then this is the problem, and this question in the another worksheet, the first question. So you can put the question number, because without question number a person will not be understanding which answer is this. So we should give the question number also. Sometimes we can give the question number at the middle. So let us go to the next question. Second question: a pentagonal prism, base edge 25 mm, height 50 mm, is resting on one of its base corner on the ground, and the base edge opposite to that corner is parallel to HP. Its axis is parallel to VP and inclined 60 degrees to HP. Draw its projections. First I need to draw a pentagonal prism. So first to draw pentagonal prism, I need to take a pentagon, polygon. Number of sides are 5. So draw the prism here like this. So the base edge is given as 25 mm and the height is given as 50 mm. So now this pentagon base corner is resting on the ground, base corner. So base corner I am taking other side of the base corner, that is resting on, or otherwise any one corner is resting on its base on the ground. So whichever the side you are assuming which is resting on the horizontal plane, that you try to make it on right side. So if you carefully observe this solid, this base edge is parallel to VP. That means this base corner also I can keep, but I will try to rotate in such a way that the base edge, base corner which is resting, I will make it at the right side. So to make that, I will just rotate this solid to 90 degrees. So now this edge, base edge, is perpendicular to vertical plane, and the base corner below to this base corner, that base corner is on the horizontal plane. So when I rotate this to 60 degrees, that base corner will be resting on horizontal plane, and this base edge will be still parallel to horizontal plane. So this is the simple position of the solid. I will draw the front view and top view of this, then I will rotate this solid to get the final view. So now I will copy for the second position. I will copy this solid and I will rotate this solid to 60 degrees. I will rotate this solid to make 60 degrees. So like this. So 60. That is already 90 degrees is there. So I need to rotate this. Already it is 90 degrees. So I need to rotate in such a way that it should make only rotation of 30 degrees. So now this exactly it should rest on horizontal plane. So what I will do, I will first select this. I will move this to some place. Then I need to first actually rotate in such a way that this is resting on horizontal plane. So I will move in such a way that it should be, this edge is not at all visible now. Still I need to rotate. So now this is the edge which is resting on horizontal plane. So I will move this edge to the corner point, and then I will move this to exact position. Exact position is, it should be on the same line. It should be on the same line, strictly speaking. So I will be keeping this solid on the same line. So this is how actually you need to move exactly in the 3D. Of course you need not to know all these things, only in order to understand how it will look like the front, the two stages of problem. I am actually making this, otherwise all these things not required. So now if you go to the if you go here, so I think it is appearing. Now let me see the front view how it is appearing. So it should move further. So I will move this solid further some horizontally. So now if you go, so further I will move some more. So now this is the final position of the solid. So in order to get this final position, first what I do, I will place the solid in the simple position and then rotate the solid with the required position. So here why I am doing these two stages, because in the front view, if now we will draw the top view here and we will project the front view. Then if you go to the front view, if you go to the front view of these two solids, so the two solids, now you can able to see the front view. This is the front view in the simple position. Then if you rotate this front view with the required angle, you will get the third view. So this is the view 2 we are saying. The view 2 and view 3, the shape is same, but view 2 will be rotated with the required angle and we are getting the third view. So here we will get the same nomenclature, only thing is axis will be making 60 degrees with the horizontal plane. Then we will draw the projections and we will get the final view. And that if you want to see, you can go to the top view. If you go to the top view, you can able to see the final top view like this. So this final top view will be projecting from the view 1, and we will also draw the projection from the view 3. So final top view, that is view 4, will be seen here. This question says a pentagonal prism is resting on its base corner on the ground, and base edge opposite to this base corner, base edge opposite to this base corner is parallel to HP, and axis is inclined to 60 degrees to horizontal plane. So whenever the base is parallel to horizontal plane, so now the base is making some angle with the horizontal plane, so that we need to first make it parallel to horizontal plane for the simple position. Then we will be drawing the other view. So now I will be copying this solution. The entire thing I could have copied. So now here, now let me first erase this, and here instead of square pyramid, the prism is there, the pentagonal prism. So this pentagonal prism is resting on its horizontal plane, on its base. So now I will keep this for time being here. So now I will draw a pentagon by taking the polygon command, and the number of sides are 5, and the edge length is given as 25 mm. Now the problem says any one of its base corner is resting on the horizontal plane. Whichever the base corner is resting on the horizontal plane, that corner or the edge you bring it to right side. So now I will rotate the pentagon with 90 degrees. Sorry, I will rotate this pentagon with 90 degrees, and this is the base corner, so better we will keep this base corner in the opposite. So I could have given minus 90. So now I am rotating with 180 degrees. So now I will keep some distance in order to avoid the confusion of the notation and the dimensions. Now this is the pentagonal prism, so it will be, we can able to see only the top view, only one base we can able to see, the bottom base cannot be seen. So now I will draw the projections. So if I draw the projections from each point, so these two will coincide, so I am drawing the projection from here and I will draw projection from here. So now this is the bottom base. So bottom base I will be drawing like this, and I know this is the axis center is here and projection line till here, and the height of the prism is 50. Now I will copy the bottom base in order to make the top base. So this is the top base. Now again you draw a line from here to here and here to here. These all will become the vertical edges. Now this will complete the first the first stage. Now let me match the properties. Now this is the top view, so I will match the properties of this line to top view. Again I will match the properties of the front view. So this is the front view, and these all lines are belongs to front view. This is the front view, this is the front view, and then the axis line, this is the axis line. Let me first convert the projection lines. These all are projection lines, and this is the axis line. You convert this into axis line. So now with this I can complete the front view, and I will give the notations now. So to give the notations, I will bring these notations from here. So copy the notations. So here if you see, here is the A, B, C, D, E, which is bottom base, and 1, 2, 3, 4, 5 is the top base. So let me give the notations. This is like A comma B, A comma 1, and this is a B comma 2, and this is a C comma 3, and this is a D comma 4, and this is a E comma 5, and this is apex O. So apex O. So here also some people they will say apex O and O dash, so I will be keeping only apex as O, or otherwise axis, sorry, it is not having apex, it will be having only a axis. So then this is the top view, and let me draw the front view notations also. Before giving the notation, always it is preferable to give the dimensions, because the dimension line should not coincide with the notation. So it is 25 mm. So now you see here, because I am not knowing this dimension line will be coinciding, that is why I given the dimensions here. So that is why first if you give the dimensions, so you can avoid coinciding the dimension line with the notation. So now this is 50. Now I need to give the notations here, that is front view. So it will be front view will be this, and this are useful in the front view. So I will bring the notations here. So now this will become A, B, C, D, E, up to E is required, and up to 5 is required here. So now I will move the top base. Let me take here this time top base as a dash, B dash, because anything I can take. This is A dash and a B dash also here, because both are at the same place, and this is C dash, and this is a D dash, and this is the E dash, and again the 1 2 3 I will give. This is the 1 2 3 is this is the 1 dash, is the 2 dash, is the 3 dash, is the 4 dash, this is the 5 dash. So with this I given the notation. Now the first stage is over. So now I will go to the second stage. I will delete this, because this I given because of matching the properties. So I will delete this diagram. So now I need the extension of this axis. So I will move this y some more distance, and then I will extend this line. Now I will copy this, because this is not the final view. So the final view, it is actually rotated view. I will copy this here, and now, so I will on ortho, I will copy here. Now the axis is making 90 degrees with the horizontal plane. This should be make 60 degrees. So now I will take a rotation command, rotate command. So this edge, this base corner, I am actually resting onto the horizontal plane. So take the base point as this, and then the rotate minus 30 degrees, because already it is making 90 degrees. If I rotate 30 degrees, it will automatically will make 60 degrees. Then draw the projections. So now here, if I draw the projection, it will touch this the block. So I will a little move above. I will little move the left side, or maybe above, so that it will avoid the intersection of this block. So now I will draw the projections. I will draw the projection line from here. So initially I will draw the projection lines with some the more length. Then I will draw the projection line from here with full length from all the points, and I need to draw the projection from here also, and draw the projection from here also. Now you see how many projection lines are coming, all are coinciding with each, but still I need to draw the projections, and I should not get confused. So now I will usually get confused, because there are many notations are there, 1 2 3 4 5, which are the bottom base, but which point is the one bottom base, where the bottom base is actually appearing. So now if you see the leftmost corner to rightmost corner, I already told you whatever is there above this line will be visible. So that means the total top base will be visible. First let me draw the top base. The top base will be ABCD and ABCD. Let me take the notations, and I will keep the notations here. So I will copy these notations, ABCDE up to here. So where is A? So I need to locate A. So there is one more procedure. We can also even the mark a point onto this projection. So if you take point PO, so we can able to mark point here. So this is A dash and this is A. These two are coinciding here. So this becomes A. And now the point is not visible. So point visible, there is one more option is there, the point to point mode. Need to on point mode. So the point mode 3, if I keep, so sorry, so that way also we can draw the points. So then we can able to mark the point, then it will be visible actually. So now let us say this is A, so I will keep the notation A here. So keep the notation A here. So this is A, and B over here, and C, because the C is coinciding here. So this is C, and D is actually D is here. So the D and D is here. So these two are matching here, are coinciding here, and this becomes the E. So this is the top base. A, B, C, D, E is the top base. So now you try to draw the top base with the line. So draw a line from A to B, B to C, C to D, D to E, and E to A. So now remaining all things are projection lines. I can change the properties of this projection line. This is the projection line. These all are projection lines only. These all are projection lines only. So I will draw the projection lines. This also projection line, this also projection line. So even the axis also I need to project sometime. So now this is the top base, so I will match the properties. So this is the top base is appearing like the green color, so I will match the properties. So this top base we can able to see, the top base we can able to see. Now let me take the bottom base. So if I take the bottom base, so now first of all I need to complete the vertical edges. What are visible, that all I can able to see. First I will mark the bottom base, which is 1 dash 1 2 3. So I will copy the notations, I will copy these notations. So where is 1? So 1 dash and 1 is matching here, so you can move this 1 dash, and this is a 2 dash, and this is 3 dash is coming here, so 3 dash, and a 4 dash which is here, 4 dash is here. So this is actually bottom the resting corner, so 4 dash is here because it will have a one base corner, so 4 dash is here. Then the 5 dash will be somewhere here. So now we need to first complete the vertical edges. So I will draw a imaginary line joining from this corner to this corner. So now all the above edges will be visible, that means the top base is visible. I made it dark, and 1A, 1 to A, that line is visible. So I will draw a line from 1 to A which is visible, and then 2 to B also visible, and 1 to 2 also visible. So 1 to 2 is visible, 2 to B also visible. So this plane is visible, and if you strictly see, all the outside edges will be visible. So you can draw a thick line, because it is the pentagonal prism. All lines will be a straight lines joining the edges. So that means these are the outside lines. These all outside lines, no hidden line will be visible, will be there. So that means this all I can make it dark. Then there is only invisible lines, that is this corner and this corner, and 4 to D, 4 to D which is below this line. So 4 to D is invisible line. So first of all what I will do, I will trim all this, the lines which are extra. So these all lines not required, so I can even trim these lines. I can trim all these lines which will avoid the confusion with the lines. So this line will up to here only, this is up to apex, so remaining all things are okay. This is up to 5 and 3, okay. So this is up to B only, this is up to 4, only. So remaining things not required, so I will just erase, and even I can even trim it. Remaining things also till here I will trim. So this is not required till here. So now I will erase this all things, because this if you erase, it seems to be very good. So now this is the bottom base. So let me draw a line which is hidden line, actually which is hidden line. From here to here also it's a hidden line, so I will erase this. So I will draw hidden line from here to here, and here axis will be there from the center, that I am avoiding, I am not drawing now. So now let me make the match properties. This top view should have in a green color, so I will make all these lines, visible lines, in green color. These all are visible lines which are in the green color. So now this is invisible line, Control Z. So this is the invisible line, so I need to make it the hidden line. The hidden line will be like this property, hidden line. So now I will make this line hidden line, and this is also hidden line, and this is also a hidden line which is actually cannot be seen in the top view. So now this axis is coming from here, because in order to avoid the confusion I am not drawing. Even I can even delete this line also. So if I delete this line also, it is good, because the top view I can able to see properly. So with this I can able to the guess how the top view is looking like. And here this also is visible, and this property also should be changed. This properties also should be changed. Now this is how the top view, final top view will be visible. So with this problem is completing. And now this line we should delete, because it is only imaginary line, in order to identify the hidden lines we have taken. So how to take the printout of this? So when you want to take the printout of this diagram, you need to first select the entire diagram. You go to the properties, you change the properties to, so let me first save this diagram. So go to the properties, select this all things, go to the properties and only change the color, and only change the color in the properties. Go to quick properties and change the color only. Don't change the line type. Quick properties, no, it is not going. So you go to the properties table, you only change the color. Color is varying, correct, but you just go to white. Then you press escape and go to control print and go to previous plot, and now you go to window. You can select here this corner point to this corner point, and drawing to PDF, everything is correct, and you scale fit to paper you can remove, and now you can see the print preview. So now if you see, now everything is perfect. Now these all the lines are dark lines, and all imaginary lines are light lines, and hidden lines are in dotted lines. So likewise we can submit this, and you can also take the printout of this with the 1:1 scale. So then later you can able to see the dimensions exactly. And here I forgot to mention the angle, so this angle also we should mention here. If you go to dimensions and give the angle, so the angle between these two, so it can be there. This is 60 degrees. So earlier also I think I have not given angle, so here also I can give the angle between these two is 45 degrees, and here axis is there. So likewise we can give the dimensions. So let me go back to the same color code. So angle between these two is 60 degrees, and the angle between these two is 45 degrees. Third question, hexagonal prism, base edge 20 mm, height 50 mm is resting on one of its rectangular faces on the ground. The base is inclined 30 degrees to VP. Draw its projections. So first I need to locate the solid between the plane of projection. This is vertical plane, this is horizontal plane. I need to solve this problem in two stages. First I need to keep the solid in the simple position, then I need to keep the solid in the inclined position. According to the problem, I need to first draw the hexagonal prism. So if I draw hexagonal prism, if I place this between the plane of projection, and according to the problem, one of the rectangular face is resting on the horizontal plane, and the base is making 30 degrees angle with the vertical plane. So this is the final position of the solid, but in this final position I can't draw the front view and top view. So I need to make this solid into simple position in the first step. So to make the solid in the simple step, I need to first see the base is parallel to which plane. The base is parallel to vertical plane. So first I will make the base parallel to vertical plane, then I will get the simple position. So in the simple position I can easily draw the front view and top view. First I need to start with the front view, because the base is parallel to vertical plane. So I need to start the front view, and I will get the front view, and from the front view I can get the top view by projecting the points. And then after I get the top view I need to rotate it to get the third view, which is with the inclined position. Then finally from the third view and projection of first view I will get the fourth view. So now if I see the front view of these solids, the front view is appearing like this. The front view of the solid is appearing like this. So here in the first stage, the solid is appearing like a regular the hexagon, and you can see A, B, C, D, E and 1, 2, 3, 4, 5, 6, which is in the front view, and the top view you will get it. And then if you see the top view will be appearing like this. This is the top view. This top view also we will easily get from projecting the points. Then once after, to get the third view, we need to rotate the second view with the required angle. So here this is the base. This base is making 30 degrees angle with the vertical plane. So I will be rotating this second view. In order to get the third view, I need to rotate the second view with the required angle. So this I will be rotating. Then afterwards, I will be knowing each and every point, corner points, base corner points of this third position. Then I will be projecting each and everything from the top view as well as front view. From the view 1, I will project and I will coincide the points and I will get the final front view. So the final front view will be appearing like this. So if you see the final front view will be appearing like this. So here this base you can able to see, other base you can't see it, but we can only see the hidden, we can't see these edges that we will be representing with the dotted line. Fourth question, write circular cylinder diameter 40 mm, height 50 mm is resting on its generator on the ground. Its axis is inclined 30 degrees to VP. Draw its projections. First I will draw a cylinder which is having 40 mm diameter. This diameter is 40 mm and the height is 50 mm. It is resting on its generator on the ground. So we are assuming a line, a line on the circumference, the curved surface. That lines we are all vertical lines we are calling as generators. So we are assuming that there is one generator which is resting on the ground, which is on the circumference of the cylinder. So then this cylinder will be shifted onto the horizontal plane on the to rest on the generator. Then this cylinder is making its axis 60 degrees to vertical plane. So now it is making 90 degrees to vertical plane, its axis. So now I need to take one more solid and I need to rotate in such a way that the axis of the cylinder is making 30 degrees to vertical plane. So now I need to rotate this. So if I rotate this, I need to rotate this to in such a way that it will make 30 degrees to vertical plane. Axis is making 30 degrees to vertical plane. So now this axis is making 30 degrees to vertical plane. Now if you see the first simple position, because the base is making, the axis is making 30 degrees to vertical plane. So first I need to see the base. The base I need to make parallel to vertical plane. So if I make the base parallel to vertical plane, I will get the simple position. Now draw the front view, and which is a circle. And if you want to see the front view how it is looking like in the simple position, so if you see the front view is like a circle. So this circle I will draw, and then I can able to draw the projections downward, and I will get the top view. So the top view will be like a rectangle which is appearing in the top view, and that is the second view. So in the second view, once after you get this second view we will be rotating with the required angle. So this angle is 30 degrees, axis is making 30 degrees angle. So once after you rotate this cylinder to make the axis 30 degrees, that is the final the third view, or otherwise you can say final the top view. Then we will get the front view by projecting the points from this view. Then finally we will get the final front view. The final front view will look like this. So here this base we can able to see, other base half of the things we can able to see. So how to locate the hidden lines? that hidden lines we will easily allocate from the other view. So from the other view, you draw a line joining the leftmost corner to the rightmost corner. Whatever is below, that all will be visible, because we are seeing the front view from this side, and other side of the corners or edges will not be visible. So accordingly, we can able to see, we can able to assume and identify the hidden lines. Fifth question. Pentagonal prism, base edge 25 mm, height 50 mm, is resting on one of its faces on the ground, and its axis is inclined 45 degrees to VP. Draw projections. Now if you see the simple position, this is the simple position of the solid, and if you see the final position of the solid, so this will be the final position of the solid, and it should be in the rotated view. So it is rotating 45 degrees with the vertical plane. So now if you see, this is the final position of the solid. Now this here base is making angle with the vertical plane. So for the simple position, we will make the base parallel to vertical plane and draw the simple position. So first we will be starting with the front view, where we will get the regular pentagon, and from that we will be getting the top view, and then the second view we will be rotating and we will get the third view, and finally we will project the third view and first view to get the fourth view. So then if you want to see now the front view of this solid, so the front view will be looking like this. So the front view of this solid is looking the regular pentagon. So then once after you get the regular pentagon, we will get the top view by projecting it. Then the other top view, the front view we will be getting from projecting from the third view and from the first view. So then if you see the top view, if you observe, this is the second view with the simple position. This same top view, if you rotate with the required angle 30 degrees, making 45 degrees angle with the axis, so you will get the final top view, or the final top view, or that is third view, and then from that we will get the fourth view.